Hello and welcome to this module on evasion attacks. I'm Harry, and in this session we're going to break down one of the most common and critical forms of adversarial attacks on AI systems. By the end of this module, you'll understand what they are, why they matter, and most importantly, how can we mitigate their impact on our AI models. Let's jump right in. To start, let's define what an evasion attack is. In simple terms, evasion attacks involve modifying input data in such a way that it deceives the AI model into making an incorrect prediction. These, these attacks exploit vulnerabilities in the model's sensitivity to certain features in the input data, whether it's images, text, or even voice. The objectives of evasion attacks vary. Attackers might want to cause misclassifications. This is when a model makes the wrong prediction, or they might aim for evasion, where the goal is to bypass some security measures completely unnoticed. In some cases, the attacker might want to manipulate the model to achieve specific or desired outcomes, such as influencing the AI's decision making into their favor. So, why do attackers use evasion attacks? The motivations can range from financial gains to privacy violations or simply undermining the reliability of an AI system. For example, in fraud, an attacker might leave an AI model used for detecting suspicious financial transactions, allowing that fraudulent activity to go unnoticed. Another motivation is privacy evasion. This means when the attacker would want to bypass AI systems specifically designed to protect the sensitive information, gaining unauthorized access to their personal or confidential data. Lastly, attackers might aim to undermine model accuracy in high stakes applications. Think like healthcare or autonomous vehicles, where these AI errors can have very serious consequences. So now let's look at some of the methods attackers use in their evasion attacks. Some techniques are surprisingly subtle. For example, an attacker can take a minor pixel change in images, altering just a few pixels, which is often more than enough to confuse an AI system. In text modifications, adding or changing just a few characters in a sentence can bypass natural language processing models. There's also data noise, where small amounts of noise are introduced into the input data, enough to mislead the model, but still appear normal to the human eye. On the more advanced side, attackers might use gradient-based methods. These attacks involve using AI models' own gradients to find optimal points where the input can be altered to create the adversarial examples. Additionally, there's optimization algorithms like fast gradient sign method or FGSM. This helps to craft adversarial examples specifically designed to trick the model they're attacking. Another advanced method is natural perturbations. This will mimic the real world changes in data, making them even harder to detect. So the impact of these attacks can be quite severe. First, they can lead to misclassification. This is where the model will make incorrect predictions. In some cases, this can cause a security breach, such as misidentifying an object in an image or allowing unauthorized access. Another risk is false negatives. This is where malicious inputs pass through the system undetected. For example, in fraud detection systems, an attacker could manipulate these inputs to evade detection entirely. Finally, these attacks can undermine the system's reliability, damaging the trust in AI systems, especially those in high stakes applications where consistent accuracy is critical. So now let's look at some real world examples to make this a little bit more concrete. In facial recognition, attackers can slightly alter an image, let's say just a few pixels. And they can then trick that AI into misidentifying a person. This has obvious security implications, especially in systems used for surveillance or access control. In text analysis, small changes to the text, like adding extra spaces, special characters, can allow spam messages to bypass email filters or even change sentiment detected in a piece of content. Autonomous vehicles are another area where evasion attacks can cause real harm. Modifying sensor inputs can mislead vehicle navigation systems, causing it to make unsafe decisions. Finally, in voice recognition systems, attackers can alter audio signals in subtle ways to bypass authentication, gaining access without the systems realizing it is being deceived. Now, here's the big question. How do we mitigate these evasion attacks? There are several strategies that can help. First, we have adversarial training. This is going to involve training the model using these adversarial examples. We want to basically teach this model to recognize and defend against these attacks. Next is going to be input sanitization. This is where we're going to pre-process the input data to detect and neutralize adversarial modifications before the data can ever reach the AI model. Another approach is going to be regularization techniques. These methods like dropout and weight decay help reduce the model sensitivity to small changes in the input data, making it much harder for attackers to succeed. We can also use ensemble methods, which involve running multiple models simultaneously and cross-verifying their predictions. If one model is tricked, the others can catch it. Finally, monitoring and detecting is crucial. Implementing real-time systems that detect potential attacks as they happen will allow for the most immediate response. So, in summary, evasion attacks are a significant threat to AI systems. They exploit vulnerabilities in models by subtly altering input data, leading to misclassifications and false negatives. The impact can be devastating, especially in systems that require high accuracy and security, such as facial recognition, autonomous vehicles, and fraud detection. However, by using strategies like adversarial training, input sanitization, and real-time monitoring, we can strengthen our models and reduce the risk of successful attacks. Thank you for joining me in this module on evasion attacks. Now, in future sessions, we'll dive deeper into other types of adversarial attacks and how we can defend against those. So I look forward to seeing you there. Thank you.